All right, today we're going to talk about something called a z-score, and I'm going to go over what that means, okay? But let's kind of review a little bit of what we talked about in the past section. So we've gone over how to find your mean, your median, your mode. We've talked about how to find standard deviations, variance, and all that stuff, okay? And so what z-scores are, it's a value that shows how many of those standard deviations a data value is from the mean. So when we are given information about the mean and the standard deviation and those kind of things, then we can actually find like specific data points that were maybe used to get there. Because sometimes you maybe are just given the information, like on those standard bell curve problems, they gave you the mean and they gave you the standard deviation, but they didn't actually give you any of the actual data points. And there might be times where they want you to find a certain data point, or they want to know, how did this specific person do? So when a z-score is positive, the data value is going to be above the mean. And when a z-score is negative, the data value would be below the mean. And when the z-score equals 0, then the data value is equal to the mean. To find the z-score, we have a formula that we can use. And remember, we had all those Greek letter symbols that we use to talk about mean and that. They're going to use those to help you with your formula. So remember, when we see some of these over here, and they kind of have it written out for you, anytime you see these symbols, it's telling you something about the data. So to find your z-score, and we just use z for the z-score, you're going to take your data value, you're going to subtract your mean, and that's going to be all over whatever your standard deviation is. Now, most of the problems that we're going to deal with today, they're already going to give you this information. They're not going to maybe expect you guys to find the mean and the standard deviation. If we really wanted to, we could have a set of data and we could do all the things with it. We could find the mean, we could find the median, the mode, we could do the standard deviation and the variance. We could do a bell curve that represents it all, and then we could come and find the z-score. And it should all make sense depending on what our data says. Okay, but they're probably not going to make you guys do all that work. And if they did, that would be like one problem, and it would be like all encompassing of the things that we've talked about. Instead, they're probably just going to give you some of these pieces, and you just have to know how to plug it in. Okay, so some examples down here. Number 1 says that we have a radar detector, and it records the speeds of a group of cars that pass by. If the mean, so I'm just going to underline important information. If the mean is 46 miles per hour, and the standard deviation is 2.8, they want us to find the z-scores for each given data value. So they're giving you the x for your formula. You have the mean and you have the standard deviation, and we want to find the z-score. So they actually are giving you everything to just plug it into your formula. Okay, so like for part A, 52 is going to go in for that x. You're going to subtract the mean, which is 46, and you're going to divide by the standard deviation, which is 2.8. Okay, and this is going to give us our z-score. So 52 minus 46 is going to be 6, and then you divide that by 2.8. And if I round here, 2.1 is my z-score. So finding z-score should not be super challenging as long as you have all that information. Okay, again, if they didn't give me all that stuff, then I would have to go back and maybe do some work, but they're probably not going to do that. So you guys go ahead and do B and C. Find those z-scores for those given data values.
You want to start with that?
Yeah, I would just round to the nearest 10. So what'd you guys get for B? What's the z-score?
3.6.
Not 3.6.
I got -1.4.
Negative 1.43. That's what I have. So you should have taken 42 minus your mean, which is still that 46, and divided by 2.8. That's how we got there. How about for C? What's the z-score? 0.4? Good. And then let's just look at that and let's see if it makes sense with what I talked to you guys about at the beginning. Because it said if the z-score is positive, that means that the data value they gave you was above the mean. And if it was negative, it was below. So if you look at the first and the last, because those are both positive z-scores, 52 and 47 are both numbers that are bigger than the mean, because the mean was 46. And B is negative because 42 is less than the mean, 46. What data value would they have to give you here in order for it to be 0?
46.
It would have to be 46. They'd have to give you the mean as the data value. Okay, so anytime that you kind of see that, you should be able to look and like see, does this make sense? Am I getting the right answer here? Okay. Now, underneath this, they're going to kind of start to switch things up on you. So maybe instead of giving you the mean and the data and the standard deviation, they might be missing one of those things. And instead, they're going to provide you with the z-score, and they're going to want you to kind of work backwards to find whatever was missing. So number 3 says the mean total or the mean number of total miles ran last week by each member on the track team was 4. Okay, so that was a mouthful, but what they told you there is that the average, your mean, was 4. So that's this value. Okay, symbolically, your mean is 4. Standard deviation is 1.2. If Clay's z-score was 2.5, they want to know how many miles he ran. So we're missing the data value. So they want us to find the x this time. So if I think about how I would set that up in my formula, I know my z-score is 2.5 because remember, we're still using this formula here. I'll just write it off to the side. We're going to put 2.5 in for z. And then in for our data value is what we don't know. So x is going to stay x right now. And then our mean we said was 4. So on the top it says x minus 4. And our standard deviation was 1.2. So now you're going to have to kind of go back and use some of your algebra skills to solve for that x. Let's get rid of the fraction first. How are we going to do that? Okay, so 1.2 times 2.5 is 3. And that's equal to x minus 4. And then what do I need to do? Yeah, add that 4 over. So what do I get for x? 7. So he ran 7 miles. Okay, number 4. A set of test papers is normally distributed with a standard deviation of 5. If Riley scored an 83 with a z-score of negative 0.4, what was the mean? Okay, so I want you guys to tell me what I should put where. What number in the problem goes where in my formula? Do they give you the z-score?
Yeah.
What is it?
Negative 0.4.
Okay, negative 0.4. Do they give us the data value? 83. They're giving you her test score this time. So that's going to go in for your x. Do they give you the mean? No, that's what they're asking for. They're saying what was the mean. So that's what we don't know. So then what's the standard deviation? 5. Be careful on this one because there's negative signs in there. So watch them as you're working throughout this problem. What are we going to do first? Yep. Okay, so take negative 0.4 times 5. That's negative 2. And now I have 83 minus the mean. Now what should I do? Subtract 83. So negative 2 minus 83 is going to be negative 85. But then that still has that negative mean. So what happens here? Yeah, essentially we're dividing by negative 1. So my mean is 85. So that's why I said watch out for your negatives. Because if you drop a negative or you forget to bring that negative sign down in front, it looks like your mean is a negative value, which would not make sense. If you think about your numbers, if you're finding average, unless you're talking about like negative temperatures. But if we're talking about test scores, I don't think anyone's probably getting a negative test score. At least we hope not. That'd be really bad. Okay, why don't you guys try 5? Okay, this is what it should have looked like when you set it up. It's a little maybe deceiving here because they say if the z-score for a 20-foot tall tree. So if you kind of skim past that, you might miss that the 20 is actually your data value. So this time we're missing the standard deviation. So we're missing the bottom part of our fraction here. So what I would have done is I would have multiplied both sides by my standard deviation to get it out of the fraction. So then I have this 1.9 with the standard deviation attached to it. And then I would have just simplified the top. So 20 minus that 14.3 can simplify to 5.7. And then you would divide by the 1.9. And what did you guys get for the standard deviation? 3. Good. All right, do we have any questions on manipulating and working with that z-score formula? Okay. That's all we're doing today.